Hello. Hello, everyone. Welcome to Theo-MathProblemSolver. In this particular episode, I'm so excited to take you through, the journey of homogeneous linear equations. In previous episodes, we've been looking at various cases where the discriminant, you know, is being restricted. But in this particular case, we are looking at a situation where the discriminant is less than zero. Now, in such a situations, we kind of confidently point out that the roots R1 and R2 of the auxiliary equation or the characteristic equation are complex numbers. Okay. Now, so this theorem says that if the roots of the auxiliary equation are the complex numbers, which is R1 and R2 being defined as that, then we have the general solution of the ODE as such. Okay, as this. Okay. Now, this is a very important theorem to bear in mind. We'll be using that a lot in solving problems. So I would want you to kind of embrace it and see how best we can use that to solve problems. So let's move on. So let's get the first problem of the day. Now, given this IVP, which is initial value problem, how do we, solve it? Now, as if you've been following us for um for from the onset of this particular episode, you would realize that we use a trick in transforming this particular ODE into an auxiliary equation. And we said that replace your y prime prime. We said that replace your y prime prime with r squared, your um your y prime with what? With r. Okay, very good. So that is what we said. That's what we said. Now, let's maybe let me change this to y. So that let me change this to y. So in which case my y is now gonna be one instead of y prime being r. So we're going to use this. So once we have this, then we can plug that into back into the ODE. And by doing so, we are going to have, you know, we're going to have r squared plus 1 equal to 0, right? So this we can also write it as what? As r squared equal to 1. Whose roots are out? So that means that the roots are gonna be plus or minus what? I, right? Good. So which means that, but remember, based on the theorem, your based on the theorem, you're going to have your, remember, if it is complex, it means that your R1 can be written as what? As what? Alpha plus IB, okay? Alpha plus, write it well, so that based on the theorem, you're going to have it as what? Alpha plus IB, and then R2 equal to alpha minus I beta, okay? Good. Now over here, we see here, over here, we can see that your R1, so let's look at the positive side. So we see that alpha is 0 over here. We see that alpha is 0 over here, and your beta is just 1. Okay, so we have your that, and then your R2 to be equal to what? Minus what? I. Does that make sense? So we are just using this. Okay, does that make sense? And also note that e to the power 0x is what? Is 1. So if that's the case, then the general solution So if that's the case, then the general solution, then the general solution becomes what? Y of x equal to what? C1. Remember, if you remember this, we're going to have it, we're going to, we have to write it as this. Remember that your alpha is already, your alpha from the problem, the alpha is just zero, your alpha is zero, and your beta is just one. So that's, it means that we are just going to, plug it back into this. Okay. So when you do that, then we should have C1 cos x plus what? C2 sin x. Does that make sense? But then because of the initial problem here, of the initial conditions here, we have to find the first derivative of the general solution. Okay? So the first derivative is gonna be what? Okay. Now remember that we have initial conditions. So remember your y of zero. So when x is zero from the general solution, when x is zero, you're going to have what? C1 being equal to 2 based on the initial condition we have here. Okay. And then we have y prime of 0 to be equal to what? Y prime of 0 to be equal to what? To be equal to C2 equal to what? Equal to 3. So this implies that our IVP, the solution of the IVP, okay, is what? Is y of x equal to what? 2 cosine of what? X plus 3 sine of what? Sine of x. Okay. And at this point, if you have not subscribed to our channel, please do so and help us to also spread this content to your colleagues and loved ones, and let's continue to create a community that is free from the mindset that math is difficult. All right, thank you so much, and have a wonderful time. Bye bye.